Awesome. Third annual GraphQL Summit. And our theme this year is doing GraphQL right. It's go time for GraphQL. We're at a point where a lot has been learned about GraphQL over the past 3 years from a lot of people that have implemented it. And we're now at a point where we can really leverage all of that to adopt GraphQL quickly at scale and do really cool things with it. So let me just start with a quick overview of where the GraphQL ecosystem is. So GraphQL has emerged, especially over the last year, as a developer megatrend. And you can see this a couple ways. One way you can see it is in Apollo client downloads. This is a nice quantitative metric. Apollo client downloads have grown from around 10,000 downloads a week at the beginning of last year to now, I think we had almost 500,000 downloads 2 weeks ago. It's just been an incredible, hockey stick of adoption. Let's put that in the context of the larger ecosystem, though. Like, what does almost 2 million downloads a month really mean? Here's some survey data I found. So in the State of JavaScript 2018 survey, they found that 83% of respondents said that they were either using or wanted to learn GraphQL. And in the Node.js Foundation 2018 user survey, they actually got in the Node community that over 20% of all Node developers said that they were using GraphQL in that survey. So that's definitely what I would call a megatrend. There's a lot of great companies behind GraphQL too. These are just some of the companies that are here in the audience today. And many of these companies, many of you are making really significant investments in GraphQL already. I'd love to see, show of hands, who's here from SurveyMonkey? I think we have 24 people here from SurveyMonkey. Who's here from Netflix? I think we have 39 people here from Netflix. Who's here from Credit Karma? I think we have 69 people here from Credit Karma. It's awesome. And I could talk about Atlassian, Expedia, Ebates, Zillow, PayPal, Braintree, EA, Microsoft, Nordstrom's, Reddit, Shopify. I could read this whole slide to you, and I wouldn't cover all the amazing teams that are here today. And so the question that this brings up for me is, why is this? There are so many things. Your time is so valuable. Your team's time is so valuable. There's so many things that you could be doing. Why are we here? Why is now the right time for a new technology in the data layer? And so to try to understand that, we at Apollo have spent hundreds of hours over the last year talking to people in the community and trying to understand how to use GraphQL, why do you use GraphQL, and what would you like to see next in GraphQL, and how can we help? And so the rest of my talk is going to summarize what we learned about that and what we're trying to do to help you based on those hundreds of hours of conversations. And that's also the basis of my belief that we're now at a point where our conference theme can be doing GraphQL right, because we have a really good handle on what that is and how to do it. So let me first start with why GraphQL? Why is now the time for something new? And I think this really is the heart of it. We used to build web apps, and web apps had this idea: you've got a web server, you've got a browser, and you're going to send HTML from that web server down to the browser. OK, Ruby on Rails, PHP, ASP.NET, Spring, Django, lots of frameworks, all LAMP stack derivatives. And over the past 5 or 10 years, we've seen a transition to a totally different architecture where you've got apps, which are actual pieces of software, not web browsers, that talk to, or if they're web browsers, they're running code for you. They're talking to services in the cloud. And what that means is now you need an API. Every app now has an API inside of it, because the app needs some way to talk to the cloud. So somewhat surprisingly, REST turns out to not be the right way to build those APIs. And the reason for that is that REST, besides being 20 years old and designed for something totally different, is a procedural API technology. And by procedural, what I mean is basically the way you use REST is you write a bunch of endpoints, which are essentially remote procedure calls. And this is a call that runs a block of code and does a thing and gives you a report of your data. So my first screen of my app, I write a first procedure call. Let's say for that first screen, I need data from the posts and the likes service. Great, that was easy. It works, perfect. But then when I go write the second screen, I need a different combination of data. And now I have to add another purple arrow that's going to go talk to a different set of services. And now, for the rest of my screens, I just have to keep on adding purple arrows. And you end up with a lot of purple arrows, and that's bad. You don't actually want the purple arrows. because every purple arrow represents code you have to write. And this is code that spans the front end and the back end. So to write that code, you have to coordinate multiple teams, because you have to do the state management on the client, and then you have to build the endpoints on the services. You end up with hundreds of these purple arrows, meaning that it's nearly impossible to fully document those purple arrows or keep that documentation up to date, meaning that maintaining all those purple arrows is probably not going to be any fun, and in fact, probably isn't going to happen the way it really should. And the real tragedy here is all of these purple arrows are code, and this is code that can't make your app good. It can only make it bad. It can only hurt latency, server load, battery life, network traffic, security. You're not going to make your app better with this by doing this code well. You're only going to make it worse by doing it poorly. So this, and at the same time, you end up tightly coupling your front end and your back end so that it's hard to change either one of those things. So you end up basically with a whole bunch of really costly boilerplate code. So if REST is a procedural approach to APIs, GraphQL is an alternative way to think about it that's a declarative approach to APIs. So we're not going to have any purple arrows. Instead, what we're going to do is we're going to have an approach where your apps simply describe their data requirements. You can just write a little GraphQL query, co-locate that with your UI components, and you've described the requirements in kind of a way that a piece of software can understand without having to be Turing equivalent or solve a halting problem. And then your services just need to describe their capabilities. And then once you've got those descriptions, what services can do and what apps need, GraphQL can be like a marketplace or a clearinghouse or a matchmaker that maps those requirements to those capabilities. And this means you have much less code. It means you have consistent performance. It means that you can easily audit your security surface. We can talk about the technical benefits, but sometimes it's helpful, I've found, to kind of put this in a broader business context. So here's my summary maybe of how to think about the business benefits of GraphQL. Maybe a good slide to share with whoever you need to talk to get permission to do this, if that's anyone but yourselves. With REST, you often end up in situations where feature development is slowed down because the front-end team is waiting on the back-end team to give them new endpoints. Whereas with GraphQL, both because you're writing less code and because you have much less cross-team coordination, you're going to be able to ship more features this year with GraphQL. And the other thing is, if you're entering new channels, if you're going to ship on iOS or Android, whereas you hadn't before, we hear from people that they can often get those apps to market months faster than if they weren't using GraphQL, because they can leverage all the data infrastructure and data fetching stuff they already built once for web and very rapidly build their iOS or Android app on top of that. So that's one benefit. Another benefit is what we often find, who's had the experience where you're using some app and there's a great experience on the web, but it's not as good on mobile, or it works pretty good on iOS, but not as good on Android. Who's ever had that experience with an app? Probably most users. It's really hard to get that feature parity and consistency across multiple platforms with REST for a number of reasons, including the fact that you end up with data fetching code that's pushed into the clients where it should have been and shared across platforms, and also just the fact that feature development is so hard. What we hear from people, empirically in the field, talking to all of you, is we find that it's a lot easier to ship consistent, high-quality user experiences across multiple platforms when you have this consistent data layer in place. Next thing, a lot of people are in a situation today where you're trying to move from a monolith to a set of microservices. And maybe you're just beginning this journey, or maybe you're halfway there, or maybe you've got it up and running, but you're still trying to figure out how to manage it and what your processes are going to be for the next 5 years. That can be really challenging with REST because the tight coupling. You've got all these apps that are calling right into your monolith, and they end up making assumptions about what your backend, making more backend assumptions about what your backend looks like than you'd really like. With GraphQL, you end up creating this abstraction layer between the apps and the services, and that makes it much easier to refactor either one of those things. You can refactor from one monolith to services, or from one set of services to a different set of services, without necessarily having to disturb all your apps in the field in the same way. Another benefit, this is one is maybe talked about a little bit less in public, but we certainly hear about it in the conversations we have in private. It can be pretty hard to secure a REST endpoint, a REST API, because you end up with hundreds of these endpoints, probably written on deadline, probably not written by your most senior team members, and every single one of those is like a little hole in your firewall exposing some unknown combination of data based on the parameters you pass to it. So how are you ever going to audit that entire security surface, every single REST endpoint you've ever had? Can you even list all the REST endpoints you have? Whereas with GraphQL, you can manage and secure your whole API from one central location because you have this declarative understanding of what it is. You don't have all those pink arrows that you have to analyze. And finally, GraphQL has a lot of benefits for public APIs because what we often find with public APIs is, put it this way, if you thought it was hard building the APIs that your front-end team needs so they could build their applications, and if you thought you're constantly having to coordinate between the front and the back-end teams, imagine how hard it is when you're building for partners or API consumers that don't even work at your company. There might be a 6-month change cycle, generously, if that partner needs a customization. But they also have the same needs that your internal app teams need. So with GraphQL, you can build a much more flexible public API, and that enables a lot more applications for your partners and creates a much better experience for your mutual user. And that's what's driven companies like GitHub and Shopify to adopt GraphQL for their public API. But if we zoom out a little bit, all of those are pretty nuts and bolts technical benefits, immediate benefits. But there's a bigger picture here about what the graph is and what it means. When you have one graph of all your data, there are many uses that become possible from that. And I'm not going to go into too much detail right now in interest of time, but on the left, I've listed some of the business benefits, some of the leverage you can get once you have this graph. So we've talked a lot about app development. That's our main focus. We've talked a little bit about partner enablement, in other words, public APIs. But there's so many other uses and ways your organization can benefit from GraphQL if you have your data in a graph. There's business intelligence. You can take all that data in your graph, and you can very easily get it into Tableau or Looker or Power BI. Not just the data in the graph, but the way people are using the graph. You can say, let's look at my graph logs and say, do people search more for ice cream on hot days in a particular country, right? We are hearing about GraphQL, once you've got this graph, we hear about it being used by product management to understand the way people are using your products or see what data is available. We hear about it being used by customer support to be able to dive in and diagnose what's going on with the customer or even call GraphQL mutations directly. There are some amazing possibilities for auditing and compliance. Do I want to know absolutely for sure who's retrieved a particular medical record? Well, I can do that just by looking at the graph access logs. There's a lot of really cool possibilities when you have a unified way of thinking about your app data. And that's even on top of all of the technical leverage you get to have a central way to think about access control, demand control, the change management around your schema, and a lot more benefits that we're going to talk about in the rest of my talk and also the rest of today. So it's no wonder, given all these really cool benefits on top of 20-year-old REST technology, that we're seeing not just tactical adoption of GraphQL, where people are using it for a feature or two, but strategic adoption of GraphQL, where people are rolling it out across their whole company and making big investments, big bets on it. One example is Airbnb. And I'm going to have Adam Neary up on the stage right after me, who will tell you a lot more about this. But I just want to, as a teaser, I want to read you this quote from Adam about what's going on at Airbnb. Apollo will power all of our customer experiences across web, iOS, and Android. And another example, CNBC. Ashish Gupta, who runs front-end engineering at CNBC, says, we truly believe that GraphQL is the next generation data layer for applications. This isn't just another JavaScript library of the week that's going to help you build a feature faster. It is that, but it's also a much bigger picture about how you can manage data as we go forward into the modern cloud era. And these are just a couple of the companies that are making big strategic bets on GraphQL. And we'll hear a lot more talks about why this is and how people are doing it and how to do GraphQL right over the next 2 days. So that's why I said at the beginning that it's go time for GraphQL. But my other promise was that we know how to do GraphQL right. So we're learning more stuff every day, but we're now at the point where so many people have adopted GraphQL at meaningful scale that we're at a point where we can kind of summarize some of the best practices about how to do it right. So what we've done is we've taken everything we've learned over those hundreds of hours of conversations with you, and I've summarized it down here into what I'm going to call 10 GraphQL values. And these values sort into 3 categories that I'm going to go through. There's a set of integrity values, there's a set of agility values, and there's a set of operational values. So I'll give you a quick overview of this. You're going to find these ideas threaded through all the talks at the conference today. And we'll also have a lot more to say on our blog, and there's lots of places for this conversation to continue. But I just want to start with this overview so you're oriented as you think about the talks that you're going to see over the next 2 days. So integrity values. The integrity values are really all about the idea that you want one graph. You don't want a lot of little individual graphs. Because the more people are using your graph, the more valuable it gets. And also, if you had if you had dozens of little overlapping but incomplete, but inconsistent and incompatible implementations of a graph, it would be pure chaos. So the way you want to think about a graph is as one graph for your company. At the same time, it's important not to create a monolith. You may have, we already have people that are looking at having hundreds of developers, if not more, consuming their graph, and many different services teams all building services that feed into the graph. So at the same time, it's important that, moving on to the second value, that you have a federated implementation. You need a way for many different teams to all work together to build that one graph for your company and decouple their release cycles and decouple their design processes and actually decouple the way the services run. So you want to have one graph, but you want to have it federated. And to enable that, you want to track your schema in a registry. This is another way of saying, you use version control for your source code. You should probably have a consistent way of tracking your schemas too. You should have a source of truth for your schemas, and you should understand how your schemas are changing. Because unless you can write down what your schema is, and you have a source of truth for that, it's hard to say that you have one graph, and it's hard to look for inconsistencies that might exist across your company. Even if you just have a client and a server, you still want to have a source of truth that coordinates the many versions that are existing as you develop your graph between that client and that server. Second set, the next four values are the agility values. These are about how, if we brought up this idea in 1970 and someone said, how would you implement this? Someone would probably design a Gantt chart with this water flow process where over the next 3 years, we were going to do requirements gathering across our whole company, understand what everyone wants in a graph, and maybe 3 years from now, we'd have a broken implementation of it. But we as an industry have learned so much about agile software development processes. And GraphQL is such a great fit for this. GraphQL is designed to be incrementally adoptable. You don't have to stop the world and rewrite everything. You can implement GraphQL a bit at a time. And when you do that, you get all the benefits of an agile approach to software development. So there's a few key points in doing agility right with GraphQL. One point is you want to have an abstract schema. So you don't want your schema to be coupled with the way your backend is actually implemented. You want to respect that your backend is going to change over time. So the schema should be something that kind of floats on top of your backend. And it should be oriented around the needs of the product. In particular, the good way to approach it that we've heard over and over again is you want to build your schema kind of just in time. Or put another way, you want to build your schema against real-world use cases. So when someone needs something out of your schema, that's the time to add that field. That's the time to add that object. Don't speculatively add a bunch of stuff where you're not sure that you're going to need it. Likewise, you want to maintain that schema over time using agile schema maintenance practices. So you're going to add fields as you need fields. Sometimes you're going to find that you need to remove a field or that you want to deprecate a field. It turns out GraphQL provides really good tooling that lets you manage this process in an agile way. It's not a version process where I release a version and then next year I release another version, next year I release another version. It's a far more agile way to manage schemas made possible by all this great tooling. We'll see some examples of that in a second. On the performance front, performance is also something you want to approach incrementally, interactively, agilely. There's that expression, premature optimization is the root of all evil. I think that's something I learned back when I was a C++ coder. And the same thing is true with GraphQL. GraphQL gives you such a great set of tools to understand the actual usage patterns of your APIs that you can incrementally make whatever changes you need to the way queries are executed, the way your services are structured, in response to the actual demand patterns you're seeing. And there's a very powerful set of functionality around that. You can even do things like predictive load planning and provisioning. So you can say, if I ship this, how much load might it create? And are my services set up for that? So you want to take full advantage of all those capabilities. And finally, there's another way that you can be agile with GraphQL. And that's to take everything you know about this graph, all the great graph metadata, how it's being used, and put that, you want to thread that through the entire software development cycle. When you're in your editor writing, like pressing the first key to write the first line of code for your application, you want all of that data about the graph to be there at your fingertips. And likewise, when you're checking code in your CI/CD process, you want the graph metadata there. You want that to be ubiquitous throughout your whole process. And the final three values, I know it's a lot of values, the operational values. This is about how you run GraphQL and make it stable, scalable, and secure. So there's, what auth looks like for GraphQL is a combination of both access control and demand control. Access control, who can do what? Demand control, how much of that can they do? Like, can you send an expensive query or only an inexpensive query? How many can you send? Because GraphQL gives you a lot of power. With that comes, you could say great responsibility, or you could say the importance of good governance. And you don't want to let just anyone on the internet send you just any GraphQL query. You need a way to manage and think about that process. Structured logging is another really amazing thing that GraphQL can do. GraphQL logs are not just a bunch of random text logs. You actually know in a very structured and fine-grained way exactly who is doing what as a virtue of GraphQL's strongly typed declarative nature. And there's so much benefit you can get out of that. So you should have a unified strategy for that. And finally, when you think about how to operate GraphQL, there's so many capabilities here, so much tooling. You want to adopt a layered approach to this. Just like with HTTP, you adopt or with REST, you adopt a layered approach. You're going to have a proxy. You wouldn't have a client talk directly to a web server. You want to have a GraphQL layer in your architecture to manage some of these considerations for you. That's not to say that your backend shouldn't speak GraphQL. That's fine. But you don't want to take every single consideration relating to GraphQL and put it in every single backend process. All right, so the 10 GraphQL values, we'll see this threaded through the talks today. Now moving to a little bit more of an Apollo-specific note. What this raises the question is, how do you do all this stuff? Well, the other thing we've been doing over the last year or two at Apollo is we've been working to put GraphQL, the whole thesis of the company is we want to put GraphQL in the hands of every development team. And so our next step on that is an announcement I have today, which is the new platform we're launching today, the Apollo GraphQL platform. So this is a complete set of functionality based on everything we've heard from all of you about what you need to roll this out at many different, at many different scales and in many different use cases. Let me walk you through what's inside the box as part of our vision here of this being a tool set that you can use to implement GraphQL quickly on your team. So to start with, there's, of course, the Apollo open source libraries. This is our heart and soul. It always will be. Apollo client, Apollo server. I think probably 90–95% of GraphQL implementations are built on top of this. And next to that, we put some great dev tools to support you in using those libraries and tools. So Chrome dev tools have been out for a while. They're great, but we're adding on top of that a great IDE plugin for VS Code initially, but with more coming, and a CLI to help you manage all the functionality. OK, so far, things you've seen before probably could have predicted. But today, what we're adding underneath that is a schema registry. I talked about the importance of schema registries and how they're like version control for your schema. This is a free service. It's a SaaS service we are operating for the benefit of the community. And we think, you don't have to use it, but we think it's really powerful when you're able to actually have a source of truth to understand what your schemas are. So it's part of our platform vision. And then on top of this, we add another layer of services. So, because there's more than just your schema that you need to track in a graph. You need to track all the clients that could use your graph. You need to track all the operations that they might perform, especially in a pre-registered query situation, which is how many people implement security. And you also need a way to perform that structured logging, and that's the trace warehouse in the diagram here. Ingesting all those traces, the trace that is produced when every GraphQL operation executes, and having the right pipeline to get intelligence of that by aggregating them, reviewing them, or picking out individual traces so you can understand what's going on in your graph. So this is another core graph service component. And then once you've got those graph services, what you can layer on top of those graph services is a set of workflow and policy modules. So access control, demand control, schema change control, ways to leverage all of that information you have about your graph and how it's being used throughout your development cycle, throughout your company. Oh, and one more thing. Very excited to announce today the first version of our distributed GraphQL query execution engine, which lets you take a single GraphQL query and then divide that over many backend services by creating a query plan and understanding how that query gets federated over many different services. So it looks to the client like one server, but it's actually distributed over many different GraphQL microservices. So I'll take a quick spin through some of the functionality here. So you see how this all fits together. So this is the new Apollo platform VS Code plugin. So we're writing a GraphQL query here. And the really cool thing is I have access to my entire schema right here in my editor. I don't have to go to any other page. This is coming live off of the schema server. And I can see all the fields that are available on all the types. I can see the documentation. So I don't even have to leave my editor to have an always up-to-date, always complete view of exactly what data is available in my graph. And as you can see, as I'm recursing into the query, it's context sensitive. So I actually know in the query, just like in Graphical, what fields are available at any given point in the query. And I can see the types and the signatures for every single one of those fields. I can even, if I'm going to pass an argument, I've got the documentation on the arguments. And I can even provide interactive completion. So this size argument is an enum. I can actually let you pick from the available enum values right inside your editor. So that's pretty cool, but watch what's about to happen next. What's that 4 milliseconds that appears next to is booked? That's the 4 milliseconds of latency that we are predictively telling you that field is going to contribute to running your query. That's based on live production data that's being plumbed into your editor. So we take all the traces, we run them through an aggregation pipeline, and we push that into your editor so you know what's expensive and what's inexpensive. Not 3 weeks from now when you go into production, but as you're actually writing your code. Now, another thing. I said this was coming from the schema server. We're going to do one more thing here. So this is using a version of the schema that's the production version of the schema. And now what we're going to do is we're going to switch to a different version of the schema. We're going to switch to the upcoming version of the schema that isn't live yet, but it's what we all need to be targeting. And you can see a little squiggle appeared under name instantly when I switched to that schema. And that's because that name field just got deprecated in the new version of the schema. So you can see the note about the deprecation right there in your schema, and you can fix it. Now the field's called full name because we are doing an agile incremental change to our schema. So that's how you can put all these tools together, the IDE integration, the schema registry, the trace warehouse, to deliver an incredibly agile, rich development experience around GraphQL. Here's another example. What does CI and CD look like in a GraphQL world? So this is the dashboard of Apollo Engine. And you can see how now, let's see, so we're looking at that new schema. This is the schema on the schema server that we're viewing here in our dashboard. And what we can see is the changes to the schemas that have happened recently. We can track those changes. This is integrated with version control. So this is all coming right out of Get, out of your Get process. We can see the changes that are happening as the schema changes over time. And guess what we can also see? We can see that this particular commit actually broke some clients. 5 broken queries. Well, what are those 5 broken queries? We can zoom into that. And what would I mean broken, first of all? Well, what I mean by broken is we've actually used a slice of production traffic to validate the new schema. So in this window of time, we found that there were clients that were making API queries that were valid before, but with the new schema changes are no longer valid. And so we can zoom into that. We can see that because we have a client registry, we can identify the particular client that the schema change impacted. So was this like, I don't know, some like little prototype or toy, or was this our main app? And in this case, it was Space Explorer on iOS. We can see the exact queries, because we have an operation registry, that were broken by the schema change. And we can even see like how much those queries are actually used and how it's important. So hopefully, these 2 examples paint a picture of the power of GraphQL, about how you can go into your IDE and how you can go into your whole workflow process to have a 360-degree picture of the data that's available to you. And I would just say, as a community, we're only beginning to scratch the surface of this. We're only a couple years into GraphQL. This is going to be like any other foundational technology, where we're still going to be finding new cool things we can do with this stuff for the next 5 or 10 years. One more thing. I can't mention federated execution without telling you a little bit about how it works, so I'll just do a super high-level thing. Let's say you've got this incoming GraphQL query. We're looking for recommendations for a user for products they might want to purchase. And we also want to know if those products are in stock. So to do that, we're going to need to talk to 4 different microservices: product, accounts, inventory, and recommendations. Now, we don't want to create a monolith at the center of our architecture that joins all those 3 together. We want those 4 teams to be able to work independently. So here's what we do. We send the query to the Apollo gateway, which is a new Apollo system component as part of that purple layer. And the Apollo gateway constructs a query plan. And the query plan, just like a query plan in a database, this is a distributed query execution engine. So we can see how are we going to execute that query. And what it uses to produce the query plan is a set of service definition files. So you've loaded the service definition files for all these backend services into the gateway. You don't have to write any code in the gateway. It can work from those declarative service definition files to produce this query plan. And we can see in the query plan, there are 4 services that the query is going to need to talk to. And first, we have to talk to accounts. And then, based on what we got from accounts, we have to go talk to recommendations. And then, based on what we got from recommendations, we can go to product and inventory in parallel. That's pretty cool. And then you can take, then we gather up all that data, we summarize it, we join it, and we assemble it into the final result that's sent to the user. Wicked cool stuff. So I'm almost out of time, so I won't spend too much time here, but I just want to let you all know we are committed. We built this because we want to see GraphQL adopted everywhere, and we want to see it reach its full potential. So some of this is commercial. That's part of how we, and I labeled the layers to show which was which. That's part of how we as Apollo make money and fund the development of GraphQL. But we're committed to offering the community edition to this that includes all the essential stuff, the schema registry and explorer, all the basic stuff that everyone needs to run this, free to any query volume forever. Then we have a variety of plans starting as low as $49 a month. You can check it on our webpage. It has all the functionality. And if you are an enterprise user, we have a whole bunch of options for a version of this that meets your needs, including a 24/7, 365 SLA for the entire Apollo platform. So that includes Apollo client and Apollo server. You can run this in production, and we'll support the whole thing. We've been, like I said before, Apollo client and Apollo server are our heart and soul. At the same time as we've been building this, over the last year, we've been continuing to push Apollo client and Apollo server development forward. And we also have launches on that front. So this week we're launching, I guess I should say releasing in this case, Apollo server 2.2. Apollo server 2.2 has an entirely new request pipeline. This is a way that you can slice and dice and configure the way any GraphQL request is handled inside Apollo server. This is the functionality that we use to build all of that Apollo platform functionality. You can use it too to build cool stuff like that, or even build your own version of all that functionality if you don't like ours and want yours. And likewise, we're releasing Apollo Client 2.5. This has integrated state management. So we've seen how great Apollo Link State has been for giving people a unified way of managing all the state, not just the state coming from the server, but all the state in your application using one GraphQL-based interface. So we're making that a first-class concept in Apollo Client 2.5. The other thing is we've made massive performance improvements based on years of experience now running GraphQL at scale in the client at ever more demanding applications at higher and higher scales. And now you benefit from all that wisdom from all the community members who've been running at that scale. One other announcement. As many of you have probably heard, it's a very exciting time in the GraphQL community where there is now an effort to build a GraphQL Foundation. So what this means, GraphQL has always been an open standard, and we've had a great GraphQL working group that's been meeting over the past couple of years to push GraphQL forward. GraphQL has now become so important and used at so many companies, and there's so many opportunities ahead of us where we need to really come together closely as a community that it's time for a foundation for GraphQL so that we can coordinate all the many uses of GraphQL and so that we can have a good forum for evolving the GraphQL standard faster. So we're really excited to come together with Linux, Facebook, Linux Foundation, Facebook, and many of the other top users in the GraphQL community to form this foundation. But I want to phrase this as an invitation. We are only at the beginning of this process. We want to include representatives from all the constituencies in this room. So we're looking for more people to be founding members of the foundation. So if this is something that might be interesting to you or your company, whether you're implementing GraphQL tools, because as an open source project or as a company, or whether you are making a big investment in GraphQL at your company, or whether you're just an end user, we want to have all those things represented in the technical community of the foundation. So please reach out to us if it's something that you're interested in getting involved in. So finally, I just wanted to thank a few people. We have a tradition at Apollo where we love to do shoutouts, where we point out something we think is awesome, we all clap for it. So I just want to recognize Ivan Goncharov. Ivan is one of the unsung heroes of the GraphQL community. He does so much work to maintain the specification. He's been the backbone of the GraphQL working group. And we don't hear his name on stage as often as we should. So can we all give a round of applause for Ivan and his great work on the GraphQL specification? I want to recognize Prisma, Hasura, and Neo4j. These are 3 teams that are doing amazing things to push the boundaries of GraphQL, come up with new ways to use it, new ways we can get benefits from it that's even far beyond everything I've talked about in the talk, about how you can build new applications on GraphQL quickly, about how you can use GraphQL to query a database. Really amazing cutting-edge work that's pushing the community forward, so let's have a round of applause for them, too. I hope you don't mind if I quickly thank the Apollo team. They have worked so hard over the last year to do everything we do on Apollo Client and Apollo Server while also getting the whole platform together, while also running on this conference. And so let's give them a round of applause and thank them for their hard work putting this together. I want to thank our sponsors, without whom this conference would be impossible. GitHub, Gatsby, Neo4j again, Shift, Shopify, 8base. Thank you so much. You make it happen. And we have a lounge upstairs where you can check out all the cool things that our sponsors are doing with GraphQL, and hope you'll go check that out. Some really cool demos up there. And finally, I want to thank all of you for coming. I know there's many things you could be doing today, and I'm very grateful that you have taken the time to come spend 2 days here with us.